We're really ramping up preparations for the construction of the Ska low antenna here in Australia in 2021. The test arrays currently deployed at the site will inform the decision as to which antennas we will choose. There will be tens of thousands of antennas out at the site. This will be the largest science facility ever built, and it is only possible with the efforts of scientists and engineers from some of the world's leading science institutions.
The original idea goes back to the late 50s and was developed as a collective endeavour by Italian, UK and Netherlands engineers and scientists belonging to Astron, ENAF and University of Cambridge. And through a certain phase of prototyping, most of them here in the area, we came with this final result, which is the Ska 4.1 aluminum design. This specific design was developed by ENAF and manufactured by an Italian industry in collaboration with the Australian colleagues for the part in the site and part of the digitization.
Challenges of the SK1 are large in terms of the technical realization, the engineering design and the scientific ambitions, and that takes really a global community to achieve that.
Ska will be the world's largest radio telescope. This means that it is huge. So we need to really understand and make sure that when we put all these things here in the desert, in the middle of nowhere, that everything works fine.
So on site this week we are constructing and installing the antennas for the Aperture Array Verification System. This is the first part of the Square Kilometre Array telescope that's being built here on site at the Murchison Radio Astronomy Observatory in Australia. We have engineers and technical staff from both the Curtin University node of the International Centre for Radio Astronomy Research and from the INAF Institute, which is the Italian National Institute for Astrophysics in Italy.
The main objective of this week is to install a complete array, so to build 256 antennae to install and deploy. So by the end of this week we will have a complete station. The most exciting thing, I think, is the international collaboration for sure. So to meet people that comes from a different country from yours, understand together how to try solve a problem with a different approach.
This is the Engineering Development Array. It's exactly the same configuration as the Aperture Array Verification System, but it uses these small dipole antennas instead of the large Christmas tree-shaped Scala antennas. These bow tie antennas are the same type that are used by the Murchison Wide Field Array, which is a precursor instrument to the SKA, and it's also located here at the Murchison Radio Astronomy Observatory. These antennas have been used by the MWA since 2013, so we understand the characteristics of them extremely well. And that's why we're using them here in the EDA to compare and contrast with the Scala antennas.
Over the last 20 years we've designed this telescope. Over the last 5 years we've refined that design with our UK, Dutch, Italian, Indian, Chinese colleagues, with the very strong involvement of the SKA office in Manchester. Over the last year, led by Australia and Italy, we've brought that design to finality.
Construction of the SKA is expected to begin early 2021 for both telescopes in Australia and in South Africa. And we're all looking forward to really start building the telescope because we've been working very long on designing it, and this is really what we're doing it for.
The SKA radio telescope, once built, will allow us to tackle a lot of extremely important problems in astrophysics, ranging from cosmology to the possible finding of life on extrasolar planets. But what I think is most interesting is what we don't know. I mean, these telescopes will allow us to discover things that we, as per today, we don't even imagine.